Yeah, so very good evening to everyone. Uh, First of all, can you hear me? Am I audible?
Yes, sir.
Okay, great. And is my screen visible? Clear?
Yes, sir.
Okay, great. So welcome to this TA live session. So I am Ritviz. I am a PhD student and a Prime Minister's Research Fellow at the Department of CSE in IIT Madras. And so basically, I'll be taking these live sessions, which are intended to help you, solve some assignment problems that are taken from the previous runs of this course. So, like you are enrolled in the current run of this course, right? So, similarly, there was a previous run of this course in the last year, the year before, and so on and so forth. So, in this session, we'll basically be discussing some questions from the previous runs of this course that might help you in clearing some concepts or solving some of the assignment questions of this current run that you are enrolled in. So, yeah. So, without further ado, let's can get started. Before that, does anyone have any specific query regarding this live session? You can either unmute yourself or you can write your query in the chat as well. Okay, so I'm assuming that there are no queries. Just to clarify a few more points, so all these sessions will be recorded, and irrespective of whether you were able to attend or not, the recordings will be made available to you. So you don't have to worry about it if someday you miss the live session. Yeah, and again, this is not compulsory, so but if you are interested, you might consider joining it so that it might help you with some of the assignment questions. So yeah. Can people just give me a thumbs up or something so that I know that the messages or my audio is reaching you guys? Okay, great. Yeah, great. Yeah, uh, you can put down your hands. Yeah. Okay, great. So without further ado, let's get started. So welcome again to the first week, and in this week we'll basically be discussing some questions based on a little bit of week 0, week 1, and some basic things from week 2. Since this the week 1 contents were mostly history of AI, so most of the assignment questions would be recall based. So there's no point discussing those. Though you can just refer to the videos to answer them. So let's just start with the first question. So you must have come across the one-armed robot problem that Sir discussed in the lectures, right? So we are considering one of the questions related to that, and this is the initial state and the final state that we have to reach. And based on that, which of these actions do you think uh, are valid actions? So you can post your answer in the chat or you can unmute yourself. I would prefer that. Priyanshi, to answer your question, can I give NPTEL exam in Lucknow? So these are logistical questions regarding the course. So I would suggest you post them on the discussion forum instead because it will be better addressed there. Because so I'm not in a position to answer these. So yeah, sorry for that. But it's better if you post these on the discussion forum instead. Okay. Yeah. So yeah, does anyone want to share their thoughts on what are the correct options in this case? A. Okay, so we have an answer saying A. So, okay, let's consider the options one by one. So, put down M. So, if you remember, put down M is actually when you have a block in the robot's arm and you have to put it down on the table. But as you can see in the initial state, the block M is actually on stacked on top of another block I, right? So you can't put down M because it's not in the arm of the robot. So A is not a correct option, right? Okay, so we have a few more answers, C and D. So yeah, let's discuss the remaining options as well. So let's consider B, pick up V. So V is on the table. It doesn't have any block on top of it. So the robot is free to pick it up, right? So P is a correct option. Then let's see C, stack Y on G. Yeah, was there a query? Okay, so you're new to AI. Yeah, so if you go through the first week's lectures, no, so sir has talked about it in great detail. So I'll just give a brief overview. So basically, yeah, see, so these are a few blocks that you have. Okay, this is the initial state, and this is the final state. And you have a robot basically which has an arm like this, which can perform four functions. It can either pick up a block from the table, okay, it can unstack a block from top of another block, like it can unstack M from on top of I. It can either stack a block that it already had in its arm like this on top of another block, let's say Y, or it can simply put it down on the table instead. So these are the four options that the uh, robot has. Okay. Yeah. So coming back to this question. So option C, stack Y on G. Again, so Y is on top of W, right? It's not in the robot's arm, so we cannot stack it. So C is wrong. And then unstack R from O. So yeah, this we can do, right? Because robot arm is free and we can remove R from top of O. So B and D are the right options. So any doubt about that or any confusion? If you have a doubt, you may speak up or write in the chat box. No? Okay, if you understood it, can you write yes or no in the chat? Okay. Okay, great. So some of you have understood it, some of you have a doubt. So let's go back to it once more. So yeah, these slides are going to be shared, so don't worry. Slides and the recordings both will be shared. Option C. So C. If I, yeah. So suppose this was the robot's arm, okay? And this was a block that was in the robot's arm, okay? Let's say this is a block. So stacking would be when the robot would take this arm and put it on top of another block. Let's say here it places it. So that would be stacking on top of another block. If instead it places it simply on the table, we would say that it is a put down. The robot is putting it down on the table. Okay, and unstack would be when you would take a block from on top of another block into the robot's arm. So for example, if the robot took R from top of O and now this, so this would be an unstack thing. Or if it took directly from the table, let's say it took up G instead, then this would be a pickup. Okay, so why stack Y on G is not the correct option here is because Y is already on top of another block, and for a robot to be able to stack it on top of another or on G, it should have had Y on its arm, right? But it's not, but it doesn't, so that's why C is a wrong option. Okay, great. Yeah, so I'm glad that most of you got it. So let's move on to the next question. Now, suppose that the pickup and unstack actions take 2 units of time. Okay. And put down and stack actions take 1 unit of time. Now, what is the shortest time in which you can reach the final state? So basically, you have to use the four operations that we just saw, that is pick up, unstack, put down, and stack. Using these four operations, you somehow have to move from this initial state to the final state. Okay, so how can we do that? Right, so let's shift to the Jamboard for once. Yeah, so let me just remove all of these. Yeah, okay. So this is our initial state and we have to reach this final state. Okay, so final state has V on top of the table, right? V is on the top of the table in the initial state as well. So we don't need to worry about V. Next, what do we want? We want I, right? Now where is I in the initial state? I is over here, right? So in order for us to access I, we must first remove M from top of it, right? That's only then we will be able to access I. So the first thing we will do is we will unstack M from top of I, right? So this will not be there. And then the robot's arm will have M. Okay. Now, in order for the robot to access I, it must remove M from its arm. So the robot will then put down M on the table. So the next step would be to put down M. Okay. So if I go into, yes, is there a doubt? Okay, no doubt. Okay. So if we have a look at the final answer, so we'll go step by step, don't worry. So the first thing we did was we unstacked M from I, right? That is clear. Voice breaks. Is it better now?
Yes, yes.
Okay, yeah, great. Uh, don't worry, there is no attendance for this session. It's purely optional. So if you're interested, you may join. Don't worry about attendance. Okay, so first we unstacked M from top of I and then put down M on the table. Okay. Then we unstacked I from top of B because we want to put I on top of V over here, right? And once we unstacked I from B, we stack it on top of V. So is it clear until this point?
Yes, sir.
Okay, great. Okay, so now in the final state, at this point, we have V and I. Okay, and now we want B on top of I. Okay, so remember we had removed M and put it on the table. We have removed I and put it on top of V. And now B doesn't have anything on top of it, right? So we pick up B. We can simply pick up B and then we stack it on top of I. Okay, so we have VIB over here. Similarly, we proceed for G, Y, O, and R and finally reach the final state using these steps that are given over here. I'll give you a minute to go through these steps and convince yourselves that this is a right answer, and let me know if you have any doubt.
Hello. Yeah, good evening, sir.
Yeah, tell me, Srinivas.
Yeah, so actually, just now I joined, sir. What is the question number one, sir?
Uh, so, Srinivas, these questions will be available to you even after the session, so don't worry if you miss it. Okay.
Okay, sir.
Yeah,
Yeah, okay.
so I would have gone back to the question, but since we have a crisp time limit of 1 hour on this session, so that's why I'm trying to avoid it.
Yeah,
Okay.
okay, okay. No problem, sir. Okay, thank you, sir.
Okay, great.
Sir, what is the meaning of 2 units and 1 unit?
Yeah, so these units are basically something we have assumed in the question. So if initially we just assume that a pickup and an unstack operations is taking a 2 units of time, okay, by the robot. Let's say 2 seconds of time, and put down a stack taking 1 unit of time. So basically, we have to calculate the shortest time in which we can reach the final state from the initial state, assuming we don't take any breaks in between. So that's what we are trying to find over here.
Clear, sir.
Okay. Okay, great. So I'm going to assume that this question was clear. If not, please let me know. Let's move on to the third question. So this plan that we just saw, no, to move from the initial state to the final state, which take the least amount of time, 24 units.
Sorry to interrupt you.
Yeah, sure. Tell me.
Actually, I wanted to ask you that, like, these questions that you're discussing, like, are they related to the course, or like you have brought these questions up, or were they submitted to you somehow?
So these questions, no, as I mentioned earlier, these are taken from the previous runs of this course. Okay. So I have taken these questions from the week 0 and week 1 assignments of the previous year's course. Okay.
Okay, thank you.
Yeah. So the units are assumed, yes, Jagannath, yes. And we just have to sum them up to find the 24 units. Okay. Okay. So yeah, we just saw this plan. Okay. So let's call this the best plan to go from the initial state to the final state. Okay. So this is what this question is about. So let's call the plan which takes the least amount of time to achieve the goal arrangement, that is the final state from the initial state, as the best plan. Okay. Now, after we have achieved the final state, where do you think this particular block W would be lying? Okay, so we have arranged this V, I, B, G, Y, O, R on the final state. Where would this block W be lying? What do you guys think?
On the table.
Yeah, perfect. So if you see this this plan, we never touch W because W doesn't figure into this final state. So W will be lying on the table, like M. M will also be lying on the table. So that was a fairly simple question. So I'll move on to the fourth question. So we are done with the block and the robot arm thing, and now we are moving on to a different question. Okay, so do you remember this particular image from the lecture videos?
Showing directions.
Sorry.
Showing directions.
Yeah, exactly. So what in what context was this image used? So you have these options given to you, A, B, C, D. So the first option is to express the richness, the ambiguity, and the impreciseness of the natural language. And similarly, there are other options. So okay, so we already have a few answers. So some people are saying it's A. Does everyone agree with it, or are there some conflicts? Okay,
So option B is correct, I think.
okay. So some people
I
say it's
think it
option B.
would be correct.
Okay. Okay, so let's have a clear look at this image. So what's happening over here is, so this person is asking this policeman for directions to a certain place. Okay. And now the policeman, the bubble on from that we see on top of the policeman's head, from that we infer that the policeman has a clear image of the path from the initial point to the final point where the person wants to reach. So he has a clear map and a clear path showing the directions. So he's trying to convey it to the person, but the person, the thing that the person is receiving, he's not able to interpret what the policeman is saying in the exact way that the policeman intended to. And that shows in the form of jumbled up thoughts in the person's bubble, right? So that shows that there is a certain ambiguity in the natural language that these two people here are using, and because of that ambiguity and impreciseness, there is this issue happening. So this basically illustrates the richness, ambiguity, and impreciseness of the natural language. Okay, so A is the correct option here. The other options are not really relevant to this context, right? That's why. So A is the correct option. So if you go back to the lecture and see this exact point where this was referenced, you will get why this is the answer. Okay, so I hope that was clear, and we'll move on to the fifth question. Now, this is yeah, is there a question? Okay, so I guess not. So yeah, so this is the fifth question. So if you remember, there was a mention of anaphora resolution during the lectures, right? So okay, so we have already started receiving some answers. Yeah, Keshav, do you have
Yeah.
a question?
Yeah. Option is A.
So Keshav, if you don't have a question, I would request you to mute yourself. Yeah, thank you. Okay, so let's see what's happening over here. So we have a sentence. Elizabeth told Lily that she scolded her because she was in a bad mood. So who does she and she refer to? The first she and the last she. Okay, so let us consider our options over here. So Elizabeth told Lily that she scolded her. So this could be referring to Elizabeth, that Elizabeth scolded Lily. This could also be referring to Lily, that Lily scolded Elizabeth. Because who was in a bad mood? Again, both Elizabeth and Lily could have been in a bad mood. Okay, so what are the options do you think that could be right over here? Okay, some people are saying B, some people are saying A. So you see, while A, B, and C are partially correct, they are not entirely correct. So we cannot say for sure who both these she are referring to, right? So D is the correct answer in this case, because there is an ambiguity over here, right? Let's take another example and hope it will be clearer then. So here now we have Elizabeth told Harry that she scolded him because she was in a bad mood. So what is she referring to right now in this particular sentence? What do you think?
Say Elizabeth.
Elizabeth and Elizabeth.
Yeah, perfect. Because we have one she and only one female in this sentence. So this she must be referring to Elizabeth. So B is the correct answer over here. Fairly simple. Please let me know if it's unclear or if you have any doubt. We can go back to it. So,
Sir, can you please repeat question number 5 again?
okay, we'll just have a quick look at question 5 because it's relevant to the anaphora discussion we are having. So, see, Elizabeth told Lily that she scolded her because she was in a bad mood. Now, let's look at the different interpretations that this could have. Okay, so this could mean that Elizabeth uh, was scolded by Lily, okay, because Lily was in a bad mood. Or it could mean that Elizabeth was scolded by Lily because Elizabeth was in a bad mood. Or this could mean that Lily was scolded by Elizabeth because either Lily or Elizabeth were in a bad mood. Okay, so these she, both of them could refer to either Elizabeth or Lily. So we cannot say for sure who is this referring to. That's why D is the correct option.
Sir, as per in this question, we have two females. So would it be possible that this is making a confusion to decide who's Elizabeth and who's Lily?
Yeah, exactly. That is what is causing the confusion. So this is an example of anaphora resolution where it is difficult. Okay, so uh, there is this ambiguity induced by the natural language that we are dealing with, because of which this confusion is arising.
Okay, thank you.
Yeah. Yeah, is there a doubt?
Yes, sir,
No, sir,
that
thank you.
sentence described only.
Sorry.
Sir, that sentence described only Elizabeth, no?
That was the sixth question. Okay. So in this question, we have she referring to only Elizabeth, but in the fifth question, it could have referred to either Elizabeth or Lily. So I'll just, if we can move on from this question now, and I'll encourage you to give some time to this particular sentence and think why this could be happening. If still unclear, do raise this doubt on the discussion forum, and I will specifically address it. Okay.
Okay.
Okay, great. So let's move on to the seventh question, which is also kind of an anaphora resolution, but a slightly different sentence. Okay. So yeah, so here we have the sentence. The Millennium Falcon overtook the Imperial Cruiser because it was too fast. Now,
B.
okay, what was fast? B, Millennium Falcon. Okay, some people are saying D, some people are saying B. See, in this one, it's pretty clear, right? Because Millennium Falcon overtook something, and for something to overtake it, it must be faster, right? So B must be the right option. Yeah. So let's take another look at it. A slightly different version of the same sentence. The Millennium Falcon overtook the Imperial Cruiser because it was too slow. Now, what was too slow over here?
The Imperial Cruiser.
A.
Yeah, perfect.
Yes, sir.
Yeah. So you see, this particular word "it" has been referring to two different things in two different sentences. Here it is referring to Imperial Cruiser, and in the previous question, it was referring to the Millennium Falcon in the seventh question. Right. So again, this is kind of an example of anaphora resolution. So anaphora is basically, so in a sentence you have a word that is referenced uh, somewhere in the previous part of the sentence. Okay, so it is referenced previously as Millennium Falcon, and you have to resolve this link. So that is basically anaphora resolution, an example. Okay, so I hope that is clear. So I mean, this is pretty obvious. What were the examples that we just discussed?
It's an anaphora.
Okay, great. Yeah. So A is the correct answer. Yeah. So before moving on to the next part of the question, so is there any particular doubt till now that you have?
No, sir.
Okay. Okay. So Jagannath is asking difference in anaphora and speech resolution. So speech resolution is not something that is really relevant to us over here. So I've just included this as an option to cause some kind of confusion. But as you guys rightly recognized, an anaphora resolution is the correct option. Yeah.
Thank you.
Okay, great. So I guess there's no query till this point. So let's move on to the 10th question. So this is a bit of very initial parts of week 2. So I'm assuming that most of you have still not been able to see the week 2 videos in complete. So I have that in mind. So don't worry. And these are some basic things only that we are going to discuss. Okay. So, and this will probably, and don't worry, we'll discuss week 2 again in the next week when we meet on the next Tuesday, that is 9th. So yeah, let's just get started with this question. So this is the famous water jug puzzle. Okay, so you have 3 jugs that can hold water, and they have different capacities. So the first one is a 7-liter jug, the second one is a 5-liter jug, and the small one, the third one, is a 2-liter jug. Okay, so we call this the 752 water jug puzzle because we have 3 jugs of sizes 752. Okay, so and this is an initial state that you are given, where the first jug is completely filled with 7 liters of water and the remaining 2 jugs are empty. And the way we represent this state, okay, this is also an important thing. So how can you represent this particular arrangement in the form of a state? We can represent this in the form of a 700, that is each integer reflecting the quantity of water in each of the jugs. For example, this represents the first jug holds 7 liters, the second jug holds 0 liter, and the third jug holds 0 liter in this initial state. And from this, we have to reach the goal state wherein the first jug has 1 liter, the second jug has 5 liters, and the third jug has 1 liter. So, is the problem statement clear?
Yes, sir.
Yes, sir.
Okay.
Yes.
Okay, great.
Yes,
So,
sir.
can you guys suggest some, like, in what way can we go from the initial state to the goal state? What can
I
be the
have a
first
doubt.
Firstly, fill a 5 liter jug full.
Okay, that is one way we could produce. We could proceed.
I have a doubt.
Yeah,
Like
tell me.
after, do we have a valid move that says that if we want to drop the water from the jug, we can do so? Like,
No, so you can't drop the water anywhere else. So that is the restriction of this puzzle. So you can only transfer the liquid from one jug to another, and also you don't have a way to measure the quantity of water you are transferring. Okay, so you have to either transfer the whole water, or that is the only option that you have until the jug in which you are transferring the water is completely filled.
Sir, first we fill a 5 liter jug. Then within a 5 liter jug, we fill 2 liter jug, and we put 2 liter jug into 7 liter. After that, in 5 liter, we have remaining 3 liter water. We put this 3 liter into 2 liter jug. Means in 5 liter jug, 1 liter remaining. 2 liter jug is full. Then
Okay, it's a
yes.
it's a good attempt that you're making, Isha. So well, it's not entirely correct. So let's discuss it via our diagrams. Okay. So okay, so this is the initial state that we have, and we have to reach this goal state. Okay. Okay. So if we first transfer the 7 liters jug to the 5 liter thing, so what can we have over here? Suppose this is the 5 liter thing. Okay, we fill it with 5 liters of water, and then in this one, the 7 liter, we would have around 2 liter left. Okay, and this would be empty. But the problem that you face over here, okay, so this part is satisfied, so we have 5 liter in the second jug. But how are you going to transfer 1 liter only to this jug? That is the issue that we are facing. We can't measure 1 liter from this 7 liter jug and transfer only 1 liter to this one. So this is not the correct approach that we should take. Instead, what we can do is, first what we do is we transfer 2 liters here. So what we will have is, we will have 5 liters in the first jug, we will have 0 liters in the second jug, and we will have 2 liters in the third jug. Okay, so this is our first move. Next, what we do
Sir,
is
how
we move
will
these 2 liters into the second one. So now we have 5 here, we have 2 here, and we have 0 here again. Okay, so next again we repeat the same thing, we transfer 2 over here. Okay, so what do we have now? We have 3 here, we have 2 here, and we have 2 here. Okay, and then again we will transfer this 2 into the second one. So we will have 3 here, 4 here, and 0 here, right? Now what we can do is again transfer this 2 liters, fill this third jug completely. So we will now have 1 liter over here, 4 liters over here, and 2 liter over here. Okay, now we are
Sir,
all
I didn't understand this problem, sir.
okay. Did you not understand the problem description or the solution that we are making?
The solution, sir, solution from the beginning, the first step.
Okay, okay.
So I want doubts.
Yeah, let me just clarify this doubt and I'll come back to your doubt in a minute.
Please continue, sir. Please continue.
Yeah, I'll continue. I'll just clarify this doubt. So see, the restriction that we have on this problem is that we can either transfer the whole amount of water from one jug to another jug if it fits, or we can simply keep transferring water from one jug to another jug until the jug in which we are transferring is completely full. Okay, so having these two restrictions, and also we can't, like, if we have a jug full of 7 liters water, we can't specifically like measure 1 liter out of it and transfer it to some other jug. Okay, we don't have that option. So these are the few restrictions that we have.
So these restrictions are mentioned in the question, because I have not seen any restriction like this in the question. So how can we find out that we have these restrictions?
So if you go into, if the professor has addressed, I'm sure he has addressed the water jug puzzle in one of his week 2 lectures, so he must have described it there. So this is a pretty famous puzzle and these are the known restrictions to it, and if such a question is asked to you in an exam or something, it will either be mentioned to you, the restrictions, or if it's a popular puzzle like this, say water jug puzzle, or some similar puzzles like missionary cannibal problem or something like that, then we will assume that you have it, you know these restrictions. Okay, so don't worry if you are not aware of them right now. As you progress through the lectures, you will get familiar with it.
Okay, thank you so much.
Yeah. Okay, so the way we proceed is, so we first transfer the we first empty the first jug, the 7 liter jug, into the 2 liter jug. That is, we keep pouring from the 7 liter jug into the small jug until it is full, because it has capacity only 2 liters. It can fill only till that. Okay, so that is our first step. Then what will happen? 2 liters will be removed from here and will be transferred to this small jug. Okay, so that is what I am depicting in this first stage. So here we have 5, here we have 0, and here we have 2. Okay, and after that, in the second stage, we are transferring these 2 liters, emptying the small jug into the second jug, the middle jug over here. So that is how we are proceeding. Okay, so following these steps, we reach this fifth stage where we have 1 liter in the first jug, 4 in the middle jug, and 2 in the third jug. So we are almost there. So this is satisfied. We have 1 liter in the first jug. We are short of 1 liter in the second jug, and we are excess of 1 liter in the third jug. Okay, so what we will do, we will keep pouring from the small jug, the third jug, into the second jug until it is completely full. So what will we have now? So the first one will have 1 liter, as we already noticed. Now since the second jug is completely full, it will have 5. And since we transferred 1 liter exactly from the third jug to the first jug, right? Because it was only short by 1 liter, we will have 1 over here. So we have reached the goal state. All these are satisfied. And we took 6 steps to reach this state. So was that clear, or uh, do you need another explanation?
So clear.
Okay.
Clear, sir.
Okay, so Jagannath is asking about the application for this in AI. So Jagannath, you see, these are some of the common problems that we start with when you're teaching, when you're learning about the state space methods. Okay, so one thing that you learned through this example is you learned how to represent a particular state into a suitable notation that you could utilize in your programming, right? So there's a specific programming language for such kind of problems called Prolog, which, don't worry, is not included in this course. You don't have to worry about it, but just for your information. So this is an example of how you could use these kind of you know, representations of the state that makes it easier for you to implement algorithms that you will learn later on in this course. That here we are manually finding the path from the initial state to the goal state, right? Now, what if it's a huge state space? Okay. If it's like, for example, let's say the traveling salesman problem. I'm not sure if all of you are aware with it, but it's a kind of a problem in computer science where uh, you have to go from a certain city to another city with following a certain path that is that is give the shortest, and you have to cover all cities. Okay, so don't worry if you don't get it right now, but there can be a large number of variables and it's not possible to solve it by hand to go from the initial to the final state, right? So then we will need algorithms, and this is kind of motivating towards learning the representations of the states. So as we'll discuss a few more questions and it'll become a bit clearer. So yeah, monkey banana problem is also an example of such a problem. Okay, so if that is clear, so now let's reverse the conditions. Okay, now suppose that this 151 arrangement is your initial state. Okay, although it is mentioned goal here, ignore that. Assume that this 151 is your initial state. Okay, and you have to reach the 700 state. So taking inspiration from what we just did, so what can you think? What are the ways that we could do it? What could be the first move? First, yeah, some people are giving the correct answers. Two moves, yeah. So what could those two moves be?
First move the 5 liters to the 7 liters jug. It will be
Okay.
6 liters.
Yeah.
And after that 1 liters to 6 liters. Then it will become the 7 liters.
Okay. Yeah. Perfect. So yeah, great. You guys are getting it. So two moves is the correct answer. So now going to the 12th question. Now, do you think that was the only way to achieve this configuration, or was there a different way as well?
Yes.
There must have been a way, like maybe few steps here and there, but then yeah, to reach a certain final state, the ending steps would have been the same anyway.
Yeah, perfect. Yeah. So let me just move to my Jamboard 1 second. Yeah, so we saw that we have the 1 5 1 arrangement, and one of the ways that was suggested was we first go from this to making this 6, transferring this to this, making this 0, and then this is 1, and then finally we move this and we get a 700. Pardon my terrible drawing skills, but I hope you can manage with that. So another way we could proceed with this is we could instead of doing this, we could have done this, right? We could have made this 2 first this is 5, and this is 0, and then we move this, and then this is becomes 700, what we want to achieve. So we see there are two paths, okay, to go from this initial state to the final state or the ending state, as one of your friends was saying. So there are two paths. Similarly, so this was a simple case where there were only two paths. There might be other cases where there might be many more paths as well. So depends on what kind of initial and final state you are dealing with. Okay, so yeah, how many paths were there? So 2 is the correct answer. Now comes an interesting question. So we discussed some states, right? We saw some state representations. We saw some ways to go from the initial to the final state. Now, what do you think could be an estimate of the total number of states in this particular water jug problem, the 752 water jug problem? So
one of them may remain.
Yeah, go ahead.
13, sir. 13.
13. Okay, so how did you arrive at 13?
13, sir.
Okay.
In one way I got 7 moves. In another way I got 6 moves. All possible solutions are all valid states in the state space, and I mean that is 7 plus 6, 13.
Okay, so let's see what the correct answer might be. Okay, so I think you're missing one point in your answer, but let's discuss it. So yeah,
I think the answer should be 14.
Okay.
Because like the maximum number we can get in jug 1 is 7, the other 2 is 5 and 2. So 5 plus 2 plus 7, I guess.
Okay, that is one way to look at it. I'll just address one query posted by Jagannath in the chat. So he's asking, what is a state space? So a state space is basically a collection of all the possible states valid states that could exist in this particular problem. Okay, so for example, 700 is the state that you saw. Similarly, 151 is the state that you saw, right? So similarly, many more states could exist. So collection of all such states or a set of all such states is a state space.
Sir, I have a doubt.
Yeah, tell me.
Sir, in the previous problem, we have shown that there are two parts. Do we want to calculate both the state space in each path or in just a separate path? We want to calculate the state space. Which is correct, sir?
See, so the state space does not change. State space for a particular problem remains constant unless it's a dynamic problem where you keep including and removing states. So usually for this problem, we assume that the state space is not changing. And as far as which path to choose, as long as you are satisfying, you're reaching the final state from the initial state, you could choose any path. Also, so the thing that we discussed over here, so you see both these paths were of equal length. Okay, so you're making two transfers, transfer 1 here, transfer 2 here. Similarly, transfer 1 here, transfer 2 here. So these are both the same length paths. So this is not an issue over here. You could choose any path to go from this 151 to 700. If imagine there might have been a path, I'm not telling that there is, but if there had been a path, let's say that took 3, 4 or 5 steps to reach the final state, then you would probably prefer the path with lower number of transfers, okay, because you want to optimize it. So that is the way you could approach it.
Yes, sir, I understood it.
Okay, yeah.
Sir, question is the state space. We should calculate for the past steps only, or the failed steps also we can calculate the state space.
No, see, the state space, it's not specific to a particular initial or a final state. Okay, state space, for example, let's consider this 752 problem. Okay, it is the possible number of valid states that could exist in this particular problem, valid states. Okay, so let's make one assumption for our clarity. Let's say that we are starting with a state 700. Okay, the one we had initially as our initial state. So what is one of the states that we could reach from 700? We could transfer 2 liters from the first jug to the third jug and we could be at 502. Okay, so this is another possible state that it
State
could.
space. Right.
Similarly, another possible could be you could say this is 250, wherein you are transferring 5 liters from the first to the second jug instead. Okay, now from this 250 state, again there can be another state, right? You could transfer this 2 to the third jug and this could be 052, right? So on
Right.
and so forth. You could keep on proceeding and finding a number of valid states. Okay, valid
Right.
states means that states which are not interfering with the restrictions or the assumptions of the problem that we have assumed over here. So proceeding
There is
that
any
way, sorry.
there is any formula to calculate the state space of the three containers?
So see, since this is a very simple problem, so you can just explore manually and arrive that there are actually 14 states that are reachable from this initial. If you consider the 700 to be an initial state.
Okay, sir. 14 means initial state is 700.
Yeah. Assuming the 700 is the initial state, we will get 14 states. I'll just show you the particular state diagram.
Sir. One thing I have doubt, sir. A small doubt, sir.
Yeah, tell me.
Sir, actually for every problem there may be many solutions are there. Each and every solution is comprising of some multiple states.
Mm-hmm.
And what I want to ask you is whether the state is in the solution path or outside the solution path. Say for example, initially the 700 is one state.
Mm-hmm.
The another state is 250.
Mm-hmm.
Shall we consider 701, 710, sorry, 700 will be turned as 601,
No,
610.
see, so if you move from 700 to say 250, while you are trying to reach some final state, let's say some final state over here. Okay, so you can say that this is a state, this is a state, this is a state, but you can't consider something like that doesn't follow the that kind of contradicts the assumptions that you have made. So starting from 700 directly, you can't go to an arrangement having 6. You must follow a certain number of steps. You can reach a condition where one of the jugs has 6 liters in them, but for that you will have to follow a number of steps. So I'll just show you. So see, this is the total state space for this 752 water jug problem. So from 700 over here, you are reaching a state at the bottom where one of the jugs has 6 liters in it. But to reach that, you had to follow a number of steps. Right. So in that way, if you're proceeding with a valid states, you could say that the intermediate states that you reach are states. But you can't say that an invalid state is one of the elements of the state space.
I got it. Means whatever mess up we can create, that will also come under the state space.
Yeah, as long as it's a valid state.
Yeah.
Okay, and so another thing that I want to point out here, so these blue states you see in the middle, no, this 331, 421, 511, and 241, I've just included this for the sake of explaining an issue that was raised in the previous run of this course when this question was asked. So these blue states are basically states from which you can reach the 700 state using some transfers, but you can't reach this particular state from the 700 state. Okay, so if you kind of ignore that, then there are 14 states, but if you include that, there are 18 states in total. So I'll give you, like, I will encourage you to spend some time on it, think about it, and try to arrive at this state by yourself, manually trying to calculate the different kind of states that could be. Okay. Yeah, you will get the recording of this session, don't worry. So I'm seeing that we are nearing almost the end of the session. So before concluding, I would just like to motivate another problem to you. So this is the machinery cannibal problem, okay, that I had talked about earlier. So I'll just introduce what this problem is, and then I will encourage you to try to find a solution for it. If you face any issues, do post it on the discussion forum and I will address it. So any query related to the live sessions, I am going to address it on the discussion forum. But if you have a query related to the course content or the videos, you can still post it on the discussion forum, and Bhaskaran sir, who is the lead or main TA for this course, who has been helping you with many of your doubts, he will be addressing those queries. Okay.
Sir, will
Okay.
you share this slide, sir?
Yeah, it will be shared. Don't worry. All these slides and recordings will be shared with you. It might take a few days time, but it will be shared with you.
Okay.
Sir, will you explain this problem, additional question 14?
So I would encourage you to try to solve it on your own. But if you face any
Okay.
difficulty, please post it on the forum and we can discuss it. Or
Fine.
I can also try to include it in the next week's live session when we have it.
Okay, thank you.
Yeah, so I'll just motivate what this problem is. So basically you have a river, okay? Yeah, there are two banks, the left bank and the right bank. There are two kinds of persons on one side of the bank in the initial state. There are three missionaries and three cannibals, okay? And there is one boat. Now your goal is to move to the other side, other bank of the river. And the restrictions that you have is, firstly, the boat cannot move on its own. So for the boat to go from one bank to another, there must be at least one person in it. This is one restriction. Second restriction is that the boat can at a given point of time can carry a maximum of two people. Okay, not more than that. So that is the second restriction. And the third thing that you have to keep in mind is at any given point, if one side of the river or one bank has more cannibals than the number of missionaries, for example, if you reach an intermediate state where there are three cannibals and only one or two missionaries, then the cannibals are going to kill the missionaries. So you don't want that. You want to keep all the people alive and move them to the other side of the river. So think about it, how you can move these people using the boat from one bank to another so that you reach the goal state.
Sir, this is a session one day, first session, no, sir, today?
Yes, this is the first session.
Okay, it will be on next week.
This will, yeah, every Tuesday, 6 to 7 p.m. we will have a session, and this will continue till the course is ending. The 12 weeks of the course, it will continue.
The shortest solution of this problem would be taking one missionary and cannibal every time we cross.
Sorry, taking them?
Taking one missionary and one cannibal on the boat.
Okay, so explore that and we will see. Think whether there can be a more optimal way possible using less transfers. Think about it. Okay.
So, Kamal, at a time, you said you have to transfer only one person,
No,
including the driver.
if you have to move the boat from one bank to another, you have to have at least one person, but you can have at most two people on the boat at a given point of time.
So that includes the driver, I mean, the person who is rowing the boat.
No, you don't have to consider that. You assume that either missionary or cannibals can row the boat.
Oh, okay.
Yeah. Okay, so regarding two of the issues raised in the chat, so see, a WhatsApp group is an unofficial thing, so I can't be a part of it. So I would encourage you to post whatever doubts or feedback you have on the discussion forum, so that it will benefit the others as well. And secondly, no, there is no attendance for this live session at least, but for passing the course, I suppose there are some requirements that are given on the information page of this course. So I would suggest you check this out. Check that out. Yeah, so Portima, you are not clear about the state space 14. So since we are nearing the end of the session and this meeting might end abruptly, so I don't want to get into that, but I would encourage you to think about it, give yourself some time, and if needed, we can discuss it again in the next session or on the discussion forum. I can post a dedicated solution for it. Okay. Okay, great. So yeah, the initial state, as mentioned, is the left side that is shown over here. This is in response to an issue raised by Shrutika Amratkar. Yeah. Yeah, Michael, this is like the goat, tiger, and yeah, that riddle. Yes. Okay, guys. So thank you so much for attending this session, and I hope uh, you had some benefit from it. And let's meet next week. And next week we'll be discussing more of week 2 contents. Yeah, you can leave right now.
Sir,
Yeah, tell me.
Thank you, sir.
Thank you.
sir, I wanted to
Thank you,
ask
sir.
Very nice.
why the dates of assignment 1 and assignment 2 are clashing because both we have to submit till 10th.
Yeah, I'm aware of that. So that happened because no, you were given more time for the first week because there is a certain window in which some people might enroll late, some people might enroll early. So because of that, so if you see, since the point when week 1 quiz was launched, it's a relatively more amount of time that you have for week 2. So that's why we, in order to pace things, get things in the right pace, those two assignment submission dates are same, but from this point onwards, so after assignment 2, assignment 3, you won't have two assignments to do at that point of time. And moreover, assignment 1 is mostly recall versus a simple assignment, so you can do it like
Sir,
in a few minutes.
sir, will you please leave this recorded video on course?
Yeah, the links and the recordings will be made available to you, both of the PPT and the recording, so don't worry. It might take a few days, but it will be communicated to you.
Okay, sir.
Okay, so with that, I'll end the session here. So thank you so much for attending.
Thank you.
See
Thank
you
you, sir.
next.
Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.